All right, so let's take a look at the triangle proportionality theorem, also known as the side splitter theorem. So the triangle proportionality theorem states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So as we can see in this triangle up here, we have these parallel lines right here. And that means that it creates these proportional sides. So A over B is equal to C over D. All right, so let's take a look at our first example here. We have this triangle, and since these two sides are parallel, we could use the side splitter theorem or the triangle proportionality theorem. So I'm just going to set up a proportion as 12 over x plus 1. These sides are proportional, is equal to 9 over x. So that is my proportion, and I'm just going to solve that proportion. So cross multiply. 12 times x is 12x. Then I have 9 times x plus 1. I'm putting parentheses because I have to use the distributive property to apply the 9 with the x and the 1. So that'll be 9x plus 9, combining those like terms. Left with 3x equals 9, and x equals 3. And so my answer is 3, and if you like to check it, just plug it back in. 12 over 3 plus 1, that would be 12 over 4. I'm just plugging in 3 for x. And 9 over 3. And it makes two proportional sides. So if we reduce 12 over 4, we get 3. And if we reduce 9 over 3, we get 3. So always check your work by plugging in your value and reducing it to see if you get the same fraction. All right, so let's take a look at this example here. It says 3 campsites are shown on the diagram. What is the length of site C along the road? So I'm going to pay attention to this area right here. And I could use my triangle proportionality theorem because these lines are parallel. All right, so I can set up my proportion several ways. I'm going to set it up as 8 over 7.2. So here and here is equal to 6.4 over site C. All right. Or you could set it up as 8 over 6.4 is equal to 7.2 over C. As long as you set up corresponding sides, you're going to get the same answer. All right. So cross multiply, 8 times C is 8C. 6.4 times 7.2, that is going to be 46.08. All right, and then of course that one-step equation left, dividing by 8, and C is equal to 5.76. So my answer here is 5.76, and excuse my sloppy handwriting. All right, so let's take a look at these two right here. We can see that we have the length of an entire side of 55. So we need to find the length of this little piece right here. So if this part is 45 and we know that the entire length of this side is 55, we could simply subtract 55 minus 45, that is 10. So this side right here is 10. So now let's set up our proportions. X over 36 is equal to 10 over 45, and 45 times x, 45x, 36 times 10, 360, dividing through by 45, x is equal to 8. 360 divided by 45 is 8, and let's check it. Plugging in my proportion here, so if x is 8, that would be 8 over 36 is equal to 10 over 45. And we just want to reduce those fractions. We can reduce 8 over 36 to 2 over 9. And 10 over 45 to 2 over 9 as well. So we just reduce those fractions and it does check out. All right. So let's try the next one right here. My proportion, 30 over x plus 7. I'm just going to draw a little line here to separate my work. So that'll be 30 over x plus 7 is equal to 25 over 15. 30 times 15, let me get my calculator. Let's see, 450. And then doing the distributive property, 25 times x plus 7, so that would be 25x plus, and then 25 times 7 is equal to 175. Subtracting 175 from 450, that leaves me with 275, and then dividing through by 25. And that leaves me with x is equal to 11. So we have solved these two problems right here. Alright, so I have two problems here that I would like for you to try on your own. So go ahead and pause the video and try these two problems. Okay, so for the first one, you should have gotten x is equal to 24, and for the second one, you should have gotten x is equal to 9. As you can see here, when we set up the proportion 21 over 6, we just reduce that fraction first, but you don't have to do that. You would still end up with the same answer, so hopefully you got these two problems correct. So now we have parallel lines and proportional parts. So that basically states that if three or more parallel lines intersect two transversals, and remember, a transversal is any line that intersects two or more lines. Okay, so this would be a transversal, and this line here would be a transversal. So if three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. All right, so that means that if AB is parallel to CD and parallel to EF, then AC over CE is proportional to BD over DF. Alright, so that is parallel lines and proportional parts. Alright, so let's take a look at this figure here. We want to use this figure to complete each proportion. So we want to look for lines or segments that are in the same position. So for our first one here, we have AC. So right here will be proportional to blank over F. So D is in that same position, so it would be proportional to D over F. Alright, so for our next one, we have FE. So FE right here is proportional to C over, that would be B. So same position as well. Let me erase before I draw any more marks on here. Alright, and so we have blank over C is equal to E over F. So let's look at E over F right here, and blank over C, what is in the same position as E? That would be B. Alright, so the next one here, A over blank is equal to B over E. So A over blank is equal to B over E. My proportional relationship will be here at D, same position as A. Alright, take a look at the next one here, and again erasing, so I don't have too much on this figure here. A over B is equal to blank over E. D is in that same position. And then our last one, E over blank is equal to F over C. B would be in the same position as E. So we've completed these proportions. Alright, so we have two problems here, but we want to find the value of x using the proportional parts of these parallel lines here. Alright, so we could set up a proportion. 45 over 18 is equal to 52 over x. Cross multiply, 45x is equal to 52 times 18. That is 936. dividing by 45. X is equal to 20.8. All right, so we can see that we're just setting up proportions for these problems here. All right, so for our second one right here, the length of this entire side is 32. So if this piece is 18, we could simply subtract 32 minus 18, and that would leave us with 14. So this side is 14. I could set it up several ways. I could do 27 over 18 is equal to x over 14. I could do x over 27 is equal to 14 over 18. It does not matter. I'm actually just going to do 27 over x is equal to 18 over 14. All right, cross multiply. 27 times 14 is 378. Dividing by 18. That leaves me with 21. So I have solved for x in both of these examples here. All right, so of course you know I want you to try some problems on your own, so go ahead and pause the video and try these two problems on your own. Go ahead and set up your proportion to solve for x. Okay, so for the first one you should have gotten x equals 35. And here's the proportion here. You may have set it up differently. As long as your proportions correspond, you're going to get the same answer. And then over here, you should have gotten x is equal to 72. So I hope you got these two problems correct. All right, so we've reached the end of our lesson. As always, I want to thank you for learning with me. Some similar videos are listed here below, similar figures and proving triangles similar using those theorems there. And again, thank you for learning with me. If you like, please like, comment, share, and subscribe.